Here.
Director Daddy?
Oh, Bob's not here. Forgot about Bob.
He's in Vegas with his grandson. I may text him and try to remind him.
All right. Well, let's go ahead.
Yeah, go ahead. Yeah.
Director Wyrick?
Here.
Director Thielke? Not here.
He's not here either.
And Chair Hages?
Here. We have a quorum, so
We do. We have a quorum. Thank you.
I'll get a hold of Peter.
Yeah, I'm texting Bob.
All right, the first item is director announcements. So we'll start with Jim. Do you have anything?
No, I do not. We did not.
Bill?
Just to, again, for the record, speak what Mayor Sticks was saying. Yeah, there was a lot of discussion about Arundel at the disaster council meeting. About how to finally get something going on it.
Yeah.
From that angle.
You know, some of the bad news on the Rondo is I hike up Pratt Canyon a lot, Stewart Canyon, whatever it is. You know, there's a Rondo all the way back up into those canyons.
Yeah.
And it's
interesting. The fire department mentioned that they're going into the Santa Clara and Ventura River bottoms with mechanical means to, you know, actually isolate it and burn it. And the Chris Dance was saying he thinks the goats might help some that are being deployed right now on a prototype basis or demonstration basis. He thinks the goats might help to mitigate it. So, you know, at least there was some new information discussion.
sure.
The goats will only eat new shoots.
Yeah, I didn't think they ate any of it. He did mention if they ate too much, they get sick from eating Arundo.
Yeah, but I've had it near us, and they'd only eat the new shoots. They wouldn't eat anything that was, you know, over 4 feet tall.
So if it's mechanically cut, the new shoots come up and they'd eat that?
Yeah, but I mean, that's a vicious cycle or just a permanent cycle.
Yeah, okay.
Sorry, I'm late, guys.
Oh, there you are. All right,
Yeah,
Peter.
Held up in the canyon.
Okay, you're up. Anything on mutuals?
Nada.
Yeah, I don't have anything on Casitas. And Bob is in Vegas.
Yeah.
All right, Jordan. John, you have any comments?
No. I'm a little under the weather today. I got my second shot yesterday. I'm not real sick or anything, but I just a little tired.
Yeah,
So
that's not encouraging. I have to get mine on Wednesday.
I think it'll be okay. I mean, you know, we're doing all right.
That's good. Okay, Basin status report, Jordan.
Right, thank you very much. I'm going to share the screen here for a sec. All right, can everybody see this
Yes.
presentation now? Okay,
Yes.
excellent. We're a couple days into spring here, so we're calling this the early spring Ojai Basin conditions. Of course, as we all know, this has been pretty dry. Here's some of the numbers as of this afternoon for water year to date. You know, just over 5 inches, right around 5 inches on the valley floor, where the average is somewhere around 21¼ inches of rain per year.
Wow.
The significance of this is historic. With no more rain this year, the valley floor totals will be lowest since the 4.35 inches recorded in 1947.
Ooh.
So that will be drier than some of the driest years in the 70s, 50s, and of course 90s and into the knots.
Isn't that the year they were building Matilaha Dam?
I think, yeah, just after Matilaha. So right on time. Nevertheless, we are continuing to monitor the basin at high frequency. Down in the Keywell area, this is the download from this week. And the blue here is basically a hydrograph. The red is temperature of the water. This is at the Elrod well. And the y-axis here is in feet, effectively above the logger plus atmospheric pressure. Over the water years that we're looking at, 2021's been relatively level via this metric.
Somebody needs to mute.
Yeah, but what you write,
So
you don't
at
even know
this
what I'm
point,
doing.
let's see. Thank you, Steve. At this point, we've come up off the bottom of the 146.37 foot depth to water on the 30th of December, which is about the fall or winter low, and come up a couple feet since then, and actually come down a little bit since a mid-February high in this key well based on that metric. So it'd be really early in 2021 for us to have hit our peak already, but you'll note that we're still well above the 2018, 2017 water years, and still hundreds of feet above the historic nadirs and the 2015-16 more recent dry periods. On the discharge side, we mapped the first daylighting water in San Antonio Creek. That picturesque from Grand Avenue Bridge this week, pretty dry across the basin floor, but nevertheless at a pretty consistent location. We're seeing daylighting of groundwater coming out of the perch system. That branch upon which our GPS is set there, this is what we map at least monthly, so we have that record. But that branch has been there for quite some time now, and we've been able to actually just set that GPS on that for this photo. Outside of the city area on the west, the surface water discharge from the 22nd, this is through that 2 foot wide notch where effectively all of the drainage from much of the city comes, Stewart, Ojai, Montgomery, Fox, Barrancas. It's not that wide, it's only 2 feet. So what that trickle you see is relatively small coming out of that side of the valley. On the major discharge point, just literally a hop away from that location is the San Antonio Creek proper, where it exits the basin boundary. So we do a transect here every month to quantify the amount of surface water flow that leaves the basin. At this point, you're south of the fault, just up from Dead Dog Levee, where you've got a pretty consistent flow of water leaving the perch system at this elevation just outside of the basin boundary, where bedrock is present. You can see on the left and right sides of the bank, looking upstream here, and a little bit of gravel at the bottom of this, but relatively thin veneer over the bedrock. The depth of this pooling area, you can see the flow bypassing that tape measure, but it's only about 3 inches deep. And I think that's a significant metric, because you see this relatively wide channel for San Antonio Creek with 3 inches of water in it. It's something that's a depth metric that's used in some of the fish discussions that we might have later. So what is that quantity now? Over the course of this year, it's been pretty low flows, but nevertheless consistent, and really consistent since December. Sort of following the motif of relatively stable water levels, both deep and shallow, and flow relatively continuous and consistent. San Antonio Creek flow being about 0.6 of a CFS, and out of that Montgomery Creek through that concrete notch at 0.08 CFS. This is, of course, surface outflow. It's snapshot based, so it's just that monthly reading. We also have a logger in the creek bottom that's measuring the stage above this location, so we can then correlate these flow measurements with stage above the creek bottom. But we're getting discharge of about 30 to 45 acre feet per month out of this point, and around 210 acre feet to date for this water year. This is how that data comes about. I wanted to share this because I don't think I've shared this in a while, but On the x-axis here is basically feet across that channel, where that yellow tape is strung across from bank to bank across San Antonio Creek, where we measure it. And what we do is we measure every 1/10 of a foot or so, and that's each of those blue vertical lines that go down to the depth at which the bottom of the channel is reached from the top of the water surface. So that's stream depth. That's on the left y-axis. The full scale there is only about 6 inches. So you see that 3-inch mark is pretty consistent almost all the way across, left to right, across the stream channel. We then take the velocity of that water in each of those discretized points and calculate a stream discharge in CFS. That's the red right y-axis, and then it's incrementally graphed on the red line going across the graph. So I wanted to share this because it's that sum and that measurement that we then correlate to the actual flow that we measure at that 6/10 of a CFS or so. But you can also see that this profile is effectively the cross-section of the transect that we take, and an analog for what the actual stream looks like if one were in a snorkel or had a upside down periscope or a fisheye. This is what you'd be looking at as you would be swimming upstream toward the Ojai Basin. So that's about it for now. We'll plenty to talk about later today, but happy to take questions.
Any questions? Well, thanks, Jordan.
I think Bill's trying to ask a question. I can't hear.
Yeah, are you going to talk later about the progress on getting the well, the monitoring well, Doug?
Yes, we'll give an update on that.
Thank you.
Okay, the next item is public comments on items that are not on the agenda. Does anyone have any comments? Okay, hearing none, we'll go to the consent items, which is the approval of the minutes for December 4th, 2020 and February 25th, 2021. Have a motion?
I still move.
Second.
Call the roll.
Director Finch,
Yes.
Director Wyrick,
Yes.
Director Thielke,
Yes.
and Chair Hages.
Yes.
Unanimous, thank you.
Item 8 is the treasurer's report for February.
Richard, I'm sorry, my computer was off. I didn't realize it, so I haven't really had a lot of time to look at it. We built, if you look at February for the budget actuals, you look at that whole bottom line on that, you'll see we're up a little bit, we're up some more, and then we're down, and then we're down, and then we're up. So that's a function of the GSP charges that are coming in. And so, we seem to be doing okay. We're paying the bills. And no major expenses this month. I mean, there was Cure Groundwater had a little more expense than normal, but most of it was just pretty straightforward. And I don't know if there's anything else. You can look at the extraction charges by period, and then the grant. We haven't had a lot of activity on the grant. That's all related to the depth discrete monitoring well. So that's all I have to say.
Any questions? Comments? Have a motion to accept the treasurer's report?
So moved, Jim.
Second, Peter.
And call the roll.
Director Finch,
Yes.
Director Wyrick,
Yes.
Director Thielke,
Yes.
and Chair Hages.
Yes.
Unanimous, thank you.
Item B is the draft inter-river stream flow recommendations. Jordan or John, which one of you want to take this?
Let me just introduce it, and then I put this the Department of Fish and Wildlife page from their internet site just to give you an idea what this is all about. And then Jordan provided some comments which are draft, and I've drafted a few, but we've got to just decide whether we're going to submit something. And I think we should, because Jordan and I talked about this. It's not a very good report. A lot of just, I don't know, assumptions. They make statements with no supporting documentation. And so I think we've got to challenge them a little bit, at least with our comments, that they need to do more work before they put a document out like this.
Chair Hages?
Bill?
Yeah, I would just like to add what just John just said. It's not just that it's not just the being careless about citing sources. They misrepresented sources.
Yes.
Clearly. And I that's more than just that's an act of commission, not just omission, I guess is what I wanted to try to say, John.
Sure.
And is the 29th still the deadline?
I think so. Yes.
Okay. All right.
Yeah, Casita submitted a request to extend the deadline. I don't know whether they will or not.
Okay.
Well, in our comments, should we also include that just as a simple sentence with the comments that
Excuse me.
Jordan has come up with and incorporating Bill's?
Sure.
Yeah.
Yeah, I think in general, the whole thing was a disappointment. I mean, I think a lot of us were hoping we could get some hard information and we could at least get some idea of what the future holds. But it was terrible. And it may be that they were just pushed to get it out sooner than they were ready. I don't know.
I view it almost as something of an advantage that it was so terrible.
Yeah, I suppose. Yeah, it's pretty hard to defend. I don't imagine. I don't know what they're going to do.
Yeah, I think that's a pretty good a good summation. It seems like most of you who've read this are in somewhat of an agreement with this. The general take, and you see it in the tone of our draft letter as well as John's, that this seems to have been written relatively haphazardly almost, with relatively little long-term scientific or even anecdotal truth to it. And it's something that's, as you mentioned, it's a disappointment. And that this is at this level and potentially with a lot of legs to it that could drive policy. And as scientists, we want to inform the policy and anchor the models in reality and anchor the policy in the reality of science. Hence, we drafted this letter really relatively conservatively, I think, with respect to our comments. The comments wouldn't come from Care Groundwater. They would come under OBGMA letterhead and really coalesce both what we wrote, hopefully, what John wrote, the comments we've seen today. My thoughts were that we would literally be able to share a screen and edit and track changes, our Word documents, or perhaps otherwise coalesce them before the due date for these comments, assuming that it remains the 29th. And I'm happy to play secretary and do that right now, or we could just, if Roberta could take comments and notes and we can modify accordingly another way. But I would certainly want to make sure that the entirety of the comments that are submitted are both board approved and in with the spirit of what the OBGMA board intends.
All right, anyone have any comments, anything to add or concerns about the draft?
No, I like it. Can I make a motion to approve? Are you entertaining a motion?
Sure.
I'll make a motion that we approve sending this under OBGMA letterhead to the CDFW public comment portal with the, with Jordan, delegating to Jordan the editing function.
Yeah,
Which one, Bill, are you referring to? John's comments or Jordan's or both?
Both.
Okay.
Yeah, I would suggest that Jordan and I just work together to get a final version. And then I can email it to all of you prior to sending it out. So if you have any thoughts.
Maybe I could add to my motion that you circulate the draft, subject to any objection by any board member, prior to transmittal.
Right, okay.
And so within coalescing the two, you'll also add the sentence asking for an extension and incorporate Bill's sentence, which I can't even repeat 4 minutes later.
I think Jordan knows it.
Yeah, good. I'll second that motion.
Director Finch?
Great. Are you clear on what the motion is?
I am.
Call the roll.
Director Finch?
Yes.
Director Wyrick?
Yes.
Director Thielke?
Yes.
And Chair Hages?
Yes.
Unanimous. Thank you.
Thank you.
Thanks, Jordan and John both for putting that together. It,
Absolutely.
in many ways, it was probably easier than it might have been.
It was just tough reading, I'll tell you.
Yeah, not hard to critique.
I got to tell you, Chair Hages, looking up some of those original source citations personally, it was, let's just say, it got my heart pumping. That was an adrenaline shot going, you what? You didn't cite the whole sentence of the conclusion, just you edited the source citations for, I couldn't believe it. So it's an editorial comment.
Well, hopefully someone gets the message that you're going to have to do a better job. Hopefully before they send out the San Antonio and upper reaches of Ventura stream requirements. All right, the next item is the monitoring well. You have an update on that, Jordan?
Yes, we do. So it's John provided that as of based on last meeting's direction and finding of categorical exemption. John forwarded that to the clearinghouse, the county. It's sitting on a 35-day potential comment period. That's going to expire, I believe, mid-April. So we're looking at drilling before we meet next. I think that's the cleanest update that I can provide for you on that. Everything's going well as far as scheduling the drillers for that. So by the next time we meet, we should have a column of cuttings to share that represent the full thickness of the basin at that location. So we're looking forward to that, and happy to take any comments or questions to it. But it's going to be an exciting piece of data that we'll be able to collect there.
I would agree.
Any comments, questions? Okay, the next item is the groundwater sustainability plan update on the water budget. John?
Yeah, Trey provided some slides. I was able to incorporate them in the agenda in the event there's a problem. So at least you got those. But Trey, you going to put those on the screen?
Yeah, I'll have my colleague share his screen so he can put the slides up.
Great.
But before we get started on today's presentation, we are just wrapping up the outreach engagement plan. We just have two outstanding items. One was some outreach to the tribes. We just wanted to include documentation with that. Appreciate Roberta working with our staff, just getting some of the original documentation for outreach so we can provide it in the plan. And then finally, we were just documenting the existing surface water rights in the basin. The the State Water Resources Control Board EWRM site only has the San Antonio spreading grounds as active. There's some other inactive sites, and there may be others that are below the threshold for reporting. So we're looking into that a little bit more. I'm not sure if any of the locals have some additional information to share about potential surface diversions in the basin, but we did wanted to at least recognize that per the SIGMA requirements. And then today for you, we have an update on the water budget, but before we get into that, we just wanted to share with you a couple slides based on the previous meetings and questions that arose. In particular, we have a slide for land subsidence and also for water quality. So Devin, if you want to go ahead and present on those.
Sure. Thank you, Trey. Can everyone see the slides?
Yes.
Yes.
Okay, great. So yeah, as Trey mentioned, before we get into the water budget, just want to follow up on a few questions on the previous two presentations on land subsidence and water quality. So the first will be on land subsidence. The figure here shows groundwater elevation at key well 5 LAS and vertical displacement at that location, with the groundwater elevation on the left axis and depicted it by the blue line, and the vertical displacement on the right axis and depicted by the red line. So we looked at, the question was regarding the correlation between these two data sets. We looked into that some more and ran the correlation coefficient, which is a measure of the strength of the linear relationship between two variables. And for these two data sets, the correlation coefficient was approximately 0.075, which the correlation coefficient can range from -1 to +1, and between 0.7 and +0.7 and 1 is generally considered a strong positive linear relationship. Moving on, Jordan also provided some pressure transducer data for the Elrod well, which is near near well 5L8S, the previous well shown, just to the west, I believe. And so we also compared that pressure transducer data and plotted it with the same vertical displacement data, and found that the relationship between those two data sets, the correlation coefficient is 0, so no correlation. This would indicate a weak linear relationship or no linear relationship. Although just visually an observation looking at the data, and we adjusted it slightly, there is a potential lag time. You can see that there is some sort of relationship between vertical displacement and groundwater levels. It's just that vertical displacement potentially has a lag time following changes in groundwater levels. So moving on from land subsidence to water quality. During the last presentation, there were some questions about water quality, and we mentioned that there's some time series data available for municipal wells. So wanted to show here that for 4 municipal wells near the center of the basin, Mutual Well 4, 5, San Antonio Well 3, and Gorham Well, all of which I believe are part of the OI water system. We have time series data for these wells from the State Water Resources Control Board database. And for the constituents of concern in the basin, including TDS, nitrate, and chloride, and iron and manganese, we performed a Mann Kindle test, which assesses whether or not the data sets exhibit a monotonic or up or down trend within a selective significance level. And the significance level we used was 0.05 or 95% confidence level. So these first graphs here are showing TDS concentration in milligrams per liter on the left, on the y-axis. The blue line are the concentrations within each well over time, and the orange line is the upper MCL for TDS of 1,000 milligrams per liter. And as you can see, in all of the wells, the TDS concentrations have remained below that upper MCL of 1,000 milligrams per liter, although all of them are around the 500 or above recommended MCL. In terms of the Mann-Kindle test, the results of the Mann-Kindle test, there's no trend observed in Mutual Well 4, 5, or the San Antonio Well 3, but an increasing trend in the Gorham well.
You know, looking at the Gorham well, and it's just eyeballing it, that doesn't look like an increasing trend.
Right, so maybe the scale is deceiving to the eye here. The Mann-Kindle, we did perform a Mann-Kindle test and it said this increasing trend. Maybe it's right on the threshold of no trend to increasing, but kind of breaking it into those brackets of no trend increasing or decreasing.
It doesn't look any much different than the Mutual 05. I mean,
yeah, I would agree that from an observation of looking at this this graph here, I don't think it's a concern of an increase, but the test we performed did detect that there's an increase of some magnitude occurring.
So, but increasing, since our title here is groundwater quality, is groundwater quality actually increasing or decreasing? It's decreasing, isn't it, per the test?
At that well, yes, the test would indicate that the concentrations of TDS in that well are increasing. Although if you look at the concentrations themselves, the discrete values, they're largely the same. So
right.
What you're saying is accurate. They're largely the same. There may be an increase, but it's not a significant increase to the point where we would be concerned.
Okay.
And this map here just shows the location of the wells, so you can see where in the basin they are. They're along near San Antonio Creek in the center of the basin. The screened intervals, we don't have the exact screened intervals for these wells, but we do have the top of screen and bottom of screen, which shows that they're largely screened across similar zones, although we don't have the information on the exact screen locations. So moving along to nitrate now. Nitrate, the MCL is 10 milligrams per liter. You can see none of the wells exceeded that MCL. There was a decreasing trend in Mutual Well 5, according to the test, and increasing trend in the Gorham well. But again, Jim, the increases aren't significant that we should be concerned. Now chloride, similar situation here. There's a slight decreasing, or I shouldn't say slight, just a decreasing trend in San Antonio Well 3, an increasing trend in Gorham Well, and no trend in the Mutual wells. Again, the concentrations are well below the upper MCL of 500 milligrams per liter, and also below the recommended, so below both MCLs. Taking a look at iron concentrations in these wells, all 4 wells experienced at one time a concentration that exceeded the MCL for iron of 300 micrograms per liter. But as far as trend analyses, there's no trend in any of these wells in iron concentrations. And lastly, manganese. Manganese there's a couple occasions where it has exceeded the MCL of 50 micrograms per liter. There's a decreasing trend in mutual well 5 and then no trend in the other 3 wells. Another thing we did is we took the data that the county collected between 2010 and 2015 and published in their annual reports on groundwater conditions throughout the county, including the Ojai Basin. And we looked at the water quality, specifically the cation and anion concentrations in the wells that they sampled. And we created stiff diagrams, which gives you an idea of like a visual comparison of the chemistry and could potentially discern like different water types or water sources. When looking at this figure, the focus is on the shape of these stiff diagrams. And if you look, there's some areas of the basin where you could draw some similarities between wells and other areas where it appears the water quality is more unique and potentially influenced by recharge or flowing into the basin, and then some mixing occurring more in the central part of the basin. And that concludes the follow-up on the land subsidence and water quality presentations. Does anyone have any questions before we move on to the water budget? Okay, at this point, I'm going to stop screen sharing and allow Dan to take over. Dan Ritter is a co-worker, colleague of mine, and he will be taking over. If I can figure out how to get out of this presentation. Apologize here.
Evan, it should be at the top of your screen, I believe.
Yeah, it's because I have 2 monitors that I'm having difficulty. Let me see if I wonder if
Only we had that kind of snow in our mountains.
right. Sorry about this. Can't seem to find the controls. Can someone boot me? Oh, there we go. That worked. All right. Sorry about that. Got hung up in Zoom. So Dan, please take it over from here.
Yeah. Hopefully my screen is being shared now. And we'll talk a little bit about initial water budget analysis. The water budget analysis that we've done so far uses the Ojai Basin groundwater model. Just kind of some quick background on the model. It was initially developed between 2009 and 2011 by Daniel B. Stevens and Associates. And the model was then updated in 2014 and 2020 to include additional data and adjust the model calibration that was used. The model is actually comprised of 2 different models. The first one is a watershed model that uses code called the Distributed Parameter Watershed Model that was developed by Daniel B. Stevens and Associate. And then there's a finite difference numerical groundwater model that uses ModFlow Surfact model code. The watershed model uses inputs such as precipitation, evapotranspiration, geology, soils, and vegetation cover to estimate stream flow and water percolation in the basin. And those outputs from the watershed model are then used to provide inputs to the groundwater model for recharge and stream flow. So the water budget, or the model calculates the water budget quarterly, starting in April 1970, and using the latest update in 2020 runs through September of 2019. The model is calibrated to measure groundwater elevations at 18 wells within the basin. Calibration of a groundwater model is accomplished by adjusting aquifer properties to match the measured heads at those 18 wells as closely as possible. And per the model report from Daniel B. Stevens, they adjust 3 separate properties when they're calibrating the model. And those properties are hydraulic conductivity, or kind of the ability of water to flow through the aquifer, and then specific yield and specific storage, which are values that represent the ability of the sediments within the basin and within each aquifer unit to store water. So specific yield is essentially water stored under unconfined groundwater conditions, and specific storage is the water stored in the aquifer under confined groundwater conditions. Just a bit on the model calibration, the mean error, which is the average difference between the measured heads and the modeled heads, was negative 11.26 feet. And that number indicates that the model, that on average, the model's simulated heads are about 11 feet higher than the observed values. The scaled root mean square error is another calibration metric that people who develop groundwater models typically use to estimate how well the model can reproduce conditions that they're trying to model. And that value for this model was reported as 4.6%. Generally, a value of less than 10% is considered acceptable in the modeling community. And Daniel B. Stevens and Associates also ran a sensitivity analysis on their model to look at just what values, if they change, would most affect their model calibration and the information there. And they found that the most sensitive values, or most sensitive parameters, were recharge from precipitation and irrigation, hydraulic conductivity, and specific yield. And you know, just briefly on the right is a plot of all of the observed values that were used to calibrate the model versus what the model simulates at that particular location at that point in time when the observed value was collected. And so the dashed line there is a one-to-one line that represents, if the model was perfectly representing observed conditions, every point that was measured would fall along that line. And the x-axis here is observed values, and the y-axis is modeled values. So values that fall below that line represent times when the model is predicting a lower groundwater elevation than is observed in practice, and values above that one-to-one line represent situations where the model is overestimating heads, or predicting a higher head at a location at a specific time than was observed. So to get from there to the water budget, you know, we use the inputs and outputs that were given from the Ojai Basin groundwater model to look at values of inflows and outflows to the basin as calculated by the model. So any water budget, you know, consists of inflows of water to the basin, and then the outflows from the basin. And in the end, you know, kind of the final step we're trying to get to is to look at change in groundwater and storage in the basin. And so, you know, that calculation happens. I mean, we can do that using pencil and paper, you know, if we have good estimates for inflows and outflows. And the model does, you know, something similar, where if we sum up all of our inflows to the basin and subtract the sum of all of our outflows to the basin, we get the change in water that we have stored in groundwater in the basin. And so, you know, some of the inflows that we recognize are, you know, we can have mountain front recharge, direct recharge from precipitation across the basin. If you have an area where surface water is discharging to groundwater, that counts as an inflow to groundwater. You know, conversely, for outflows, evapotranspiration and groundwater extraction, and then also areas where, you know, groundwater discharges to surface water count as outflows to the basin, and also any water that flows out of the basin to adjacent basins. So using the model output files that we received from Daniel B. Stevens and Associates, we extracted what the model calculates as the annual change in groundwater and storage. And it does this by, or, you know, again, we do this by subtracting total annual outflows from total annual inflows. And when we have a situation where outflows exceed inflows, we have a net discharge or a decrease in groundwater and storage. And conversely, when we have inflows that exceed outflows, then we can have an increase in groundwater and storage. If you look at the chart on the right, anything below the zero line is periods where the model is estimating that there was more discharge of groundwater, more outflows than inflows, plotted in orange. And so those would be years where the model is estimating that there is a loss of groundwater and storage. And then the blue bars that are above the zero line represent years where the model is estimating that our inflows exceeded our outflows. So we had a net increase of groundwater and storage. And just in general, you know, the model tends to predict that during dry periods, you generally have decreases in storage and net groundwater discharge. And during wet periods, we have net increases in groundwater and storage. So we can take these annual values that we get from the model and we calculate what we call cumulative change in groundwater and storage. And so to do this, we just sum up every year, whether there's a discharge or of groundwater from storage or an increase in groundwater and storage. We just sum up every year, and it tells us what the model is predicting over time is happening to groundwater and storage. So the chart on the right here is the value we get when we sum those annual changes in groundwater and storage that we saw on the last slide. Anytime there's an upward trend in this graph, that indicates that the model is saying that groundwater and storage is increasing over time. And anytime there's a downward trend in the line in the graph, that indicates that there's decreasing groundwater and storage over time. When we did this for the basin model, the calculation estimated that, you know, between 1971 and 2019, that roughly 30,000 acre feet of groundwater and storage cumulatively had been lost from the basin. So that's where, you know, you get to that final point in the line on this graph, as far as what the model outputs are saying is the estimated loss from groundwater and storage.
Hey, Dan.
Yeah.
What obviously we didn't do this work with the numeric model that DB Stevens put together, what would be a good methodology to check this cumulative change in storage between 1971 and 2019? And I'm thinking of a methodology not using the model, something in GIS potentially.
Sure. I think Jordan also pointed out earlier today that this is probably a pessimistic look at groundwater and storage based on historical basin conditions. And I think the step back that generally you take is to look at groundwater elevation measurements over time, and using those elevation measurements, trying to assign some representative area that maybe those groundwater elevation measurements could cover, and then estimating your storage properties of your aquifer. So either your specific yield, if you're using groundwater elevations that you think come from a well that is in an unconfined condition, or your specific storage in a confined condition. And then it's a spatial problem of multiplying, your change in groundwater elevation times the area that you think that elevation is representative of times that aquifer storage property. And that would give you another independent estimate of what the potential change in groundwater and storage would be between two different groundwater elevation measurements. So you'd have to have a difference in a change in your groundwater elevation at a well to calculate what the potential impact of storage would be.
So let's take a pause there for a second, because I think this graph plays to a very pessimistic outlook, and I don't think the model accurately is, because most wells artesianed in 05. So, once you have most of the East End artesianing in 05, you can't be deficit from a starting point. And if your other starting point was a year when they were artesianing, and I don't think 71 was, but my memory doesn't go back that far, needless to say. So I think it's a fun theoretical exercise, but it's not an accurate thing. And I think, I'm sorry, I'm blanking on who, we've got to ground it in reality, because this paints a picture that's going to put the basin into big troubles. And that doesn't tie to some of our elevations. And Jordan, what, you have a number of that's in, I know you work off of, what do you think the total basin groundwater storage is approximately?
As we sit here today?
Yeah, the potential capacity.
Oh yeah, we go with an 85,000 acre foot storage capacity.
Yeah, so I mean, the basin's been cut in half is what this is saying, and just since 71 based on that.
Yeah.
And so I think this, it's a fun theoretical model, but we've got to bring some reality to it, because I know we artesianed in 05 in a lot of wells. So it should come right back to zero as of that point.
And Richard, could I follow up on that a little bit? I'm curious about the start date of 71. Earlier we had the basin condition report that goes back to the 40s. And if just visually, one of the biggest recoveries this basin had was from the 50s, where it hit its nadir, historically, according to the records, I believe, Jordan, to 1970. Doesn't this actually, the previous 20 years, be one of the biggest recoveries this basin ever had when the lake was built? Am I getting this wrong? Jordan, I was just asking.
Yeah, and you're right. I mean, it's a Jim and Bill, you're both right here. I think I'm going to just start with the adage that hydrogeology is not modeling, and modeling is not hydrogeology. And if you're going to bother modeling, anchor it in reality. and don't bother modeling what you can measure more rapidly and more truthfully with less error than you can with a model. And that's really the case of the Ojai Basin, which has such a large tributary area, a relatively small alluvial area, that it responds so rapidly that it will reset itself over the course of these periods, as Jim mentioned, 2005, 1953, 1969, 1970, 2005, and also Artesian in 2006, with just an average water year following a really wet 2005. So when we see a graph like this, it's really unnerving because you think, what's the term? The sky is falling. Well,
Right.
It's not, and it hasn't been since, you know, I mean, although this is my lifetime here that you're seeing on this graph, on the on the x-axis, and you know, at least 2 years past it. The idea is that, you know, it really paints a picture that is much more grim than reality. And we have the measurement to show that we were not operating in a deficit for most of these years. And it's just when you add a cumulative departure curve and try to apply it to this, it's not appropriate for this basin. And it paints a picture that there's some problem that we have to address that has already been addressed with the precipitation of 2017 and 18 and 19. So it's I think there's some value in the exercise, but as far as inducing some policy change or management based on this deficit that's shown here is impractical.
Yeah, no, and that's what I want to be very careful of, because you know, this would say, oh, we've got to cut water use by, you know, 50% or something to just have this, and that's not the case. So you know, I want to be very careful in how we let this be thrown around without some anchoring it in reality standpoints.
I don't see the value to this. I don't understand it at all. I mean, obviously, the basin filled several times through that period. So I'm not even sure, I can't understand what this is supposed to represent. I mean,
A model. It represents the model, which obviously there's some errors with the model, and I don't.
But are the errors, do they take into account the periods where the basin is full and there's a huge amount of water being either released downstream or pumped with no change in storage? You know, I mean, I just don't understand it.
Let the experts speak to that. And what is OBGM? What is OBGM?
That's just an abbreviation for the Ojai Basin groundwater model. So.
Oh, groundwater model. Okay.
Yeah. So that's just the, you know, from the modeling reports and things like that. And we do, so there are also a couple of slides here that look at this specific cumulative change in storage, breaking it down into different things within the model that maybe are a little bit instructive about where some of this, how the model is coming up with this change in storage. You know, so we can talk about that too in the next couple of slides. But yeah, I mean, you know, I think it's important to point out that models aren't perfect representations of reality, and so you have to be careful in understanding what that is. And then solutions, any groundwater model, you know, we're using multiple inputs that we're adjusting. So this also isn't like the rock solid only outcome you could come up with a groundwater model that's calibrated to the heads in the basin, because we can adjust, you know, as I said earlier, we can adjust conductivity, we can adjust our storage values. And so anything that's an unknown into the model, you know, we can adjust to come up with a different solution. But this is the calibrated solution that they came up with when they put this model together.
And the 1971 beginning date, is that just based on data availability?
Yeah, so I think the biggest issue in data availability for any groundwater model is probably groundwater extraction information. And so the beginning of the model is based on when they felt like they could reliably get information to figure out what the extraction from the groundwater basin was.
Okay.
So it's a data, it's generally just data availability.
Okay.
Well, Dan, before we move on, you know, I appreciate all the comments. You know, there could be a case here where we just have an issue with the magnitude of changes that the model could be overestimating. And I think because we were planning on using this model and the outputs of it to do some of the future forecast, I think before we move on to that next step, we really have to take a step backwards and use some additional approaches to look at changes in groundwater storage over time and technically work through some of those issues or just approaches with Jordan. Because moving forward, you know, the basin will have to report on an annual basis change in storage to Department of Water Resources per Sigma. So I think it's a good opportunity right now to come up with a sound technical approach for doing that analysis and using that in the future.
So okay, and I think Jordan's comments speak to that. We know based on some of the different well elevations. I mean, we have that ability to calculate that, not model it. And, you know, I'd have to question, based on this trend and how it doesn't anchor to reality, you know, is one of the big inputs missing? You know, Casitas water coming into the east central and east end, since you break it into three zones, have some, I mean, there's something, and this, I realize this isn't your model, and that's why I kind of concur with Richard that its value is lost because it doesn't anchor to reality.
Yeah, and I think Trey, as Trey spoke to, you know, I think the next step with some of this information is to take a step back from the model and look at developing maybe a different approach for looking at change in storage that you know, as you have said, is more anchored in reality, because there are, and we will talk about groundwater elevation measurements in a few slides, but there are groundwater elevation measurements going back through time, you know, that we can use to try to make an estimate of change in storage, and groundwater elevation measurements that are, you know, collected, you know, not haphazardly either. So we do have that information available to look at as well.
Daniel, one other thing, and I don't know if this is even a relevant order of magnitude, but certainly what the Ojai Valley Sanitary District has done to dramatically reduce infiltration of groundwater into their sewage system, collection system. Have you asked for the data from the sanitary district as to their estimates of how much reduced infiltration they have in terms of how that would affect this water budget calculations and predictions?
I haven't seen that data, and I you know, I'm not sure 100% sure how they incorporated that type of information into this groundwater model. So it's certainly possible that they looked at that as they were building this model. I'm
just saying, did they ask for the data? Because the sanitary district does have the data, and they claim a dramatic reduction
Mhm.
of the groundwater infiltration into the system in the past few years.
Yeah. I can follow up on that and see what information they have as far as how they're looking at that in the model. But that, I mean, that's also something to take into consideration in the water budget, regardless
Okay.
of what the model.
One thing, just a casual observation, but it appears to me, if you look at the years, and I'm familiar with when Lake Casita spilled, and I'm sure that probably correlates with when the basin filled. If you look at all the years where there was, or considered wet, it would appear to me that the model dramatically underestimates the inflows during those periods. The gains from those major storm years are not large, they're not large enough. I mean, it seems to be a kind of an obvious, there's obviously something missing.
Yeah, look at the gains in 2016 and 2019, how big those are, and we didn't have that much rain in those years.
No.
Compared to like 78 and some of the big 98, those 2005. It's just inconsistent.
Yeah, it's like there's a major error. Something's missing.
Yeah.
Well, we look forward to working with Trey and the team to really anchor this in reality, if it's even a useful tool, certainly before it reaches publication.
Yeah, absolutely. Yeah, and so just to discuss a little bit about, to break down some of those change in storage values a little bit more. I took the model output and divided it into using a program, divided it into three areas, that were roughly three sections that were roughly equal in area. So just dividing the basin along a straight line, west, central, and east. And in the model, the declines in each of those areas were relatively similar. I mean, you have more in the central area than the west and the east, but there's not like a significant difference between the three areas. You do see more variation in the central and east part of the basin in the model than you do in the west portion of the basin. And it just seems to be more tied to climate in those areas. And that probably speaks to, where inflows are coming from in the model, and things like that. And then, we also took the data and I just divided it by layer within the model as well. And so, I think maybe one of the things that this speaks to is most of this storage change in the model is happening in layer 2, which for most of the model represents the uppermost saturated aquifer unit in the basin. And so, as we were kind of talking about alternative methods or whatever, the model is calculating groundwater and storage or changes in storage similar to, what we would do, where it's looking at this storage property, either specific storage or specific yield, and then the changes that it's calculating in groundwater heads in each of its model cells. And so this chart tells us that layer 2 has the most change in storage, but when I've done some of these calculations using groundwater elevations independent of a model, a lot of times that's driven by your storage properties that you assign to aquifers. If the aquifer is an unconfined aquifer, you're assigning a property that's usually like 0.1, somewhere in that range. For confined aquifers, we're applying a storage property that's 10 to the -4th to 10 to the -6th, somewhere in there. And so you tend to get small changes in head in unconfined aquifers have way more influence on what the change in storage is than even larger changes in head in confined aquifers, because that number is 4 to 6 orders of magnitude higher that you're multiplying by in the unconfined aquifer. And so, potentially if you're not, in this model, if you're not representing the heads in layer 2 well in some areas, you could be driving a larger change in storage than you observe in reality, just because you're multiplying those numbers together and creating kind of that large discrepancy. So, there's the potential that some of this is driven by just not capturing those heads in layer 2 as well as maybe some of the other layers. So, and again, the model only really has storage losses from what it is terming as aquifer units, and not the areas where the semi-confining units. So, just to then step back and look at the whole basis of this in Sigma, we talk about the undesirable results that we have to look at from these two things, and so the first one is chronic lowering of groundwater levels, indicating a significant and unreasonable depletion of supply. And then the second one is significant and unreasonable reduction of groundwater and storage. And so, for groundwater and storage, what we've just gone over, again, we need to go back and maybe look at anchoring this, more closely to what historically we've seen in the basin, so that we can so that we can make sure that, what we're representing is changes in groundwater and storage, we can really determine whether those are significant and unreasonable as part of the GSP. So we'll go into here a little bit about groundwater elevation, and again, this kind of ties back to groundwater and storage as well, because this is the reality that the model at least is attempting to anchor itself to, is the heads that are measured at the wells that we have in the basin. And so just in the next few slides, we'll present some groundwater elevation hydrographs for the 8 wells shown on this map. First, we'll look at the groundwater elevations in the wells to the east and to the west. So this is the groundwater elevation charts here. The gray line that you can see kind of behind these elevation hydrographs is the cumulative departure from the mean precipitation. And so that line tells us kind of how climate is, or how precipitation is varying through time. So, if we have in that line, similar to the cumulative change in storage line, if the gray line is going down here, that means we have a drier period. And then in times when the gray line is going up, that means that we have a wetter period here. But I think the big takeaway from this chart, is that in the western portions of the basin and the eastern portion of the basin, there hasn't been a lot of variation in groundwater elevation.
Which two colors are west and which two colors are east?
Yeah, so the eastern wells are the triangles and the square, the non-filled blue triangles. So the ones at the top are the east, and the ones on the bottom, the 2 lines on the bottom, are the west.
Okay, 2 top are east, 2 bottom are west. Okay, thank you.
Yeah. So, there hasn't been actually a lot of influence of, wet and dry periods on the elevations in these wells. We actually have pretty consistent elevations through time at these wells in the east and in the west. We can take a look then at these wells in the central portion of the basin. And again, here, one of the things we mentioned earlier, as far as the record that's available, there are consistent measurements at these wells through time. In the central portion of the basin, there's a lot more variation in groundwater elevations at these wells. And you do see more influence of these wet and dry periods on groundwater elevations in the wells that we've plotted here. Just of note to the change in storage discussion, and as was mentioned earlier, 1971, where the model starts, is not at a low period, and we take the elevations through to when you hit 2015 is where you get back to some historical lows, but there is recovery as we come up into 2020 as well. So that's in looking at going back and trying to again anchor that change in storage value to some of the reality with these wells. It's looking at the fluctuations in elevations of these wells, but also making sure that we're representing the recovery in basin storage, when you have wet periods that increase the elevations at the wells, the elevation observations.
So Dan, one thing that's a bit interesting here is that if you look at the groundwater levels in this that we have for these particular wells in 1970, 1972, when the Ojai Basin groundwater model starts, and you compare them to the groundwater levels in 2020, when it ends roughly, they seem fairly similar, for at least for these particular wells, suggesting there wasn't some major change in groundwater storage. So that to me, that begs the question about what's going on with the model exactly.
Yes, and that is exactly what I was going to point out. These, wherever 70, it looks like 71 is probably just to the right of that high point, which is probably 69. And I'm a little bothered by, and I realize this is draft work product, but your undesirable conclusions 5-6 slides ago, whatever it was, undesirable results, chronic lowering of groundwater levels. And I hope you aren't going into this GSP with a bias towards all basins are going down, because I think our basin we've had the OBGMA in place, and I think by the methods that just the users have done, we have a basin that's pretty well managed, and we just need to prove it out in this process. And I look forward to your help in it, but I hope there isn't a bias that we are in a undesirable situation. So I'll just say.
Yeah, and I will just point out that those are just the definitions of undesirable results in the Sustainable Groundwater Management Act. So, that doesn't mean that this basin, that those undesirable results are occurring in the basin. Those are just like what we have to look at and determine, whether or not those undesirable results are occurring, and use that information to try to set management objectives.
Right, but I think this shows that had you not put any slide after that, after going through reality, you could have undesirable results, and then you're at question mark at best, not thing. So
yeah, no, and I do think I do think it's helpful then to look at, after looking at some of the change in storage from the model, to look at these groundwater elevations, just to look at, as you've talked about, what reality is, as we're looking and trying to establish appropriate information in the groundwater sustainability plan. So, and this is just kind of quick overview of the information that we've all gone through, or that we've just gone through. So, again, with groundwater elevations, we saw relatively stable elevations in the eastern and western portions of the basin. And in the central portion of the basin, water elevations have fluctuated with changing in climate, falling during dry periods and recovering during wet periods. One of the things that we have to do as part of the groundwater sustainability plan is set objectives for groundwater elevations. And in that process, we need to make sure that you're setting the minimum thresholds, which is like the lowest you are wanting to allow groundwater elevations to go, low enough to account for some of those variations in climate that were observed in the central portion of the basin. So we don't want to set groundwater elevation objectives that are high enough that you hit those during a dry period when you expect that you're going to recover anyway, and trigger some sort of management objective or action. And then again, groundwater change and storage. We've talked a lot about this, so we need to go back and kind of tie this back into the groundwater elevations and see maybe what the groundwater elevations can tell us about change in storage and how that relates to the model. And again, we have to set minimum thresholds for changes in groundwater and storage, but we want to be cognizant when we're doing that we account for the potential loss and recovery of storage in the basin during dry periods, so that we don't set a threshold that's too high and trigger management actions when we know that the basin historically has been able to recover from those types of situations. With that, that's kind of the end of the presentation. If there's any additional questions or comments, we can take those.
We've been talking about this model, and you have the, that does and all the reasons to look at recalibrating it or improving the calibration on the 30,000 conclusion. Does the model allow you to look at any particular snapshot in time, what the loss is according to the model? Not just at the present time, but at each snapshot of time from 1970, 71?
Yeah,
what I'm trying to get is if you can do that, and if you add that to the recorded capacity, if it's at the recorded level, if it's more than the capacity, then your model's got a problem.
Yeah, sure. No, and the way that the model is set up and the way that the output is, you can extract information, as on as fine a scale as quarterly, because it's set up to measure everything quarterly. Right. So we can't go less than quarterly, but all of that.
It sounds like there might be times where if you add the model's prediction of loss to the recorded levels, and it's more than the aquifer could hold, you got a model problem.
Sure.
And also, isn't 69, 70, wasn't that like one of the biggest rain years ever?
Yeah.
Yeah, okay.
Yeah, and again, I think there's something fundamentally wrong. It's almost as though this model, somewhat what Jim was saying, is there an assumption that this is an overdrafted basin, so it would never fill up. So you accumulate a deficit year after year after year, and there seems to be totally ignoring the fact the basin has completely refilled many times. I mean, it's without getting into the complexities of a model, it seems, if you just do a mass balance, it seems pretty simple to me that you could not accumulate a 30,000 acre foot deficit over that period. It's impossible. I don't know how you could try to calibrate. I mean, if you tried to calibrate it, what did you calibrate it, or whoever did it, what did they calibrate it to?
Yeah, and you know, I think to speak to that, I mean, I think that's why Trey is talking about, like, again, taking a step back and trying to validate what we have, you know, without using the outputs from the model. But the numerical groundwater models are calibrated to groundwater elevations at observation wells. So there's 18 wells that they used in the basin to try to estimate the values. And you know, it's certainly possible that they did a good job matching heads as on the low end of things, and not as good of job you know, when things are higher. You know, that happens in groundwater models. But you know, we can look at what the biases are and try to come up with a estimate of groundwater and storage that looks like a reasonable value that we get. And you know, and as Trey mentioned, this is, you know, you have to estimate the groundwater and storage over time, or as you provide annual reports anyway. So coming up with a methodology to use the data that we have to estimate groundwater and storage is something that needs to happen regardless.
Well, yeah, we have to do something about it, because that's not, in the climate we're in, having something like this out there is not good. We're having enough trouble just dealing with fish and wildlife, let alone this.
Well, we're going to take a step back. You know, again, this was work that other consultants had previously done for Ojai Basin GMA. We, in our proposal, had proposed to use the output from the model to do the required future simulations. But you know, given the results of the model, we definitely need to take a step back here and do some checks on this model, and do an alternative analysis of the water budget and changes in groundwater storage, and get back to the board and the technical folks to figure out the best approach moving forward.
Yeah.
Okay. Well, now we're into the hard part. Oh. Anyone have anything else? Okay. Well, the sooner we can get some more information on this, the better.
Sure.
Okay, the next item on the agenda is the Channel Keeper litigation, status of litigation. You were going to do something on this, Jordan?
I think Peter was going to speak to this, and probably Jordan as well, but you know, I guess the discussion is going to revolve around, is OBGMA going to get involved in litigation at some point? And understanding Kier Groundwater's supports other parties within the watershed, we need to have a discussion about whether he's the technical representative for OBGMA, which he is, but he may have some conflicts with other well owners. So I guess, Peter, maybe you can speak to this.
Yeah, yeah, sure. Certainly, I'll introduce it. I think, as all the board members know, OBGMA's been sitting on the sidelines of the litigation intentionally, primarily to conserve resources. You know, we've got this GSP process moving forward, which is, you know, incredibly expensive. The agency has limited budget. And if we're participating actively as a party in litigation, that would be a significant drain on the agency's resources. So the decision was made to, you know, step back, monitor the situation to the extent that that's possible as in the position of a non-party, and then in the event that it appears that, you know, our active participation in the litigation becomes necessary, then we could intervene as a matter of right, I should make clear that the statutes, Sigma statutes allow us to intervene as the GSA in the litigation as a matter of right. So we're not precluded from doing that at any point in the future. So the idea is to, monitor, see how the litigation develops, and then get involved if and when that's determined to be necessary. An issue's come up over the last couple of weeks regarding Jordan and the use of Jordan as a technical consultant in a process that has evolved. The parties to the litigation are talking about doing a site visit with the judge, essentially taking the judge around to various locales, critical points in the watershed that would be important for the judge to understand, how the overall watershed dynamic works. And so they've been talking about, different locations where that might be important. They've been also talking, as I understand it, about, how that would work amongst the parties. And the city of Ojai has been interested in having Jordan be their representative during this particular site visit. And it seems to me, and I think that the general sense of the board members, as I understand it, is that, that would be a good thing. Jordan, is probably the person of any person that knows the most about the basin, the watershed, the way that the hydrogeology works. Him being involved and trying to educate the parties and the judge to these issues, seems to be critically important. The thing that OBGMA needs to be concerned about, if it's a true concern, is that if Jordan were to get involved officially on behalf of any of the other parties in the litigation, that could preclude Jordan from acting in an official capacity as OBGMA's designated expert, if and when OBGMA were to get involved in the litigation. So essentially, the concern is that we want to keep our powder dry. We don't want to have Jordan out there, agreeing to represent in an official capacity various parties in the litigation that would preclude him from representing GMA in the future. So that's the concern. At the same time, again, the interest is to get the information out there, get the information that Jordan has available to share with the parties and the court out there. I don't see a problem with him acting as the city's designated expert. I would suggest, if there's any sort of a stipulation that the parties are considering as to, detailing how the site visit would work, that, it be made clear what Jordan's role is, who he's representing, what that capacity is, and that he's effectively, we'd want to reserve our ability to keep him, in our court as OBGMA's representative, again, if and when OBGMA were to step in and become a party to the litigation. So that, I think, is the essence of the discussion. And I think Bill, on behalf of the city, has an interest in moving forward and getting Jordan essentially, signed up to act as the city's representative. And I'll open it up to you folks to talk about it, and I'll, help where I can help.
Yep, Peter, thank you very much. I think, you kind of hit the nail on the head. The city has an interest in having, the best possible expertise in the process. Does it matter, Peter? And again, I appreciate your summary. It's very thoughtful. Does it matter that the city kind of is in a unique position of having standing in the situation in this matter, but not being a pumper? Does that matter?
Well, it's my understanding that the city is a party to
Yes,
the
that's what
litigation. Yeah, but not a pumper.
Right.
So OBGMA, if it were to intervene and become a party, would be in the same position, not a
Right.
pumper,
Right.
but a party. So I don't know that makes a difference. I think where we could really get into some difficulty, both the city as well as OBGMA, if it were to become a party, is if Jordan were to take on representation of an active pumper and who's got an interest, who's got water rights that they're seeking to protect, in the litigation. And then that would give rise, I think, to a conflict. I think the city, as being in a similar position to what OBGMA would be in, if OBGMA were to intervene, I think that helps the situation. And especially since, the city's represented on OBGMA's board.
Right.
There's a synergy there that works, and a similarity of interest
Right.
that I don't see a problem with Jordan agreeing to do the site visit as the city's representative. That doesn't appear to me to be a conflict. I think the big conflict would, or potential conflict would arise in the event that, there's a major pumper in the basin that wanted Jordan to come and be their designated expert representing their interests in the litigation.
Thank you.
I think, at least as far as the site visit goes, my understanding is that it's at least been delayed.
Yes.
So it's not a pressing issue right now.
Right. Yeah, apparently there was some things going on that have become complicated, and
Everybody wanted to go. That was the
Yeah.
problem.
right.
His
But
motorcycle wasn't big.
Yeah, so it's not as pressing at this time as we thought it might be.
And moreover, it appears to be something that would be fully scripted and detailed tour stops and fully vetted really beforehand. So, the idea is that the judge could take a self-guided tour, driving a car around and listening to an audio tape of what's going on, or reading the script himself or having the script narrated. So there's a, definitely not a pressing issue at this point. And Peter, I appreciate your insight into the nuances of conflict or lack thereof. As you all know, I've worked for a number of agencies and private and public in the watershed, almost except for the city of Ventura. And it's really key to note those nuances and walk a fine line, because I would not want to be conflicted out of the consulting role that we play for the agency first and foremost, and the other dozens of clients we have within the Ventura River watershed. But by the same metric, that experience and relationships and data collection and twisted ankles on boulders and dry creeks, and every other aspect of geologic mapping we've done, watershed boundary to watershed boundary, and hundreds, if not thousands of feet below ground surface, there's experience that we want to make sure comes to light in any kind of litigation or adjudication. So it's a difficult position. The term non-retained expert or non-designated expert or things of that nature that could maintain that but share that information in a public forum, not unlike what we do for the OBGMA, is really what we want to explore when the time comes and it is appropriate.
So is there a specific need? I understand that it may be delayed, but do we need a motion or just, so that I have no trouble with Jordan working for the city of Ojai. I think it aligns itself, as a matter of fact. And then, so is there something needed at this point in time?
If that's asked is to me, I'll take it, I'll field it. I think that in order to be able to move forward nimbly, it might be good, in order for Jordan and the city to move forward nimbly, if this comes up quickly, it might be good for this board to vote to authorize Jordan to act as the city's, non-designated expert for purposes of a site visit. Now, you don't need to take that action today. We could come back and do it at the next board meeting, or even call a special meeting, if it became, critical. But just having that, done now would take care of it. It would be of limited scope and only apply to this particular site visit. And then if other issues came up of a similar nature, the board could review those at some later point in time.
What Peter said would be my motion for Jordan to be able to work on a non-exclude, whatever the terminology was, basis for the city of Ojai, and I would move that.
This is Mark. I'll second with whatever Peter said.
No more questions. We'll call a roll.
Director Finch,
Yes.
Director Wyrick,
Yes.
Director Thielke,
Yes.
and Chair Hages.
Yes.
Unanimous. Thank you.
And the next item, San Antonio Ranch refund request.
Yeah, give you a little background. The ranch came to OBGMA and said, I think we've overpaid. And they apparently did. They have what's called a micrometer meter. It registers in acre feet, but then it's got a multiplier on the meter that's 0.0001. And I guess when they submitted their bills over that time period that I had in the agenda, they dropped a zero out of it. And so they ended up paying more than they should have. And so I don't know, I told the folks at the ranch that we'd have to bring it to the board for a refund if that's the board is so willing to do that.
Do you concur that it was an error?
Yeah, Roberta and I both looked at it. We went out to the site and then we looked at put the spreadsheet together and the information, and it's definitely an error. Based on their past history, they never use that amount of water.
So that was what I was going to ask, if this picture had been submitted, but you guys looked at the meter.
Yeah, I actually got it on my phone.
Okay.
So I took a picture of it.
Well,
Thought our charges were reasonable.
Well, and in this case, Roberta put this together, and for the first quarter of 2021, they haven't paid that bill, so we put a deduction for that.
Okay.
But you can see, at least that the fourth quarter of 2020 was, $5,400. I actually overpaid $5,400. So I'm comfortable with this. I'll make one last check with Roberta before we send out any checks or have you sign any checks. But and we went back 3 years. Peter maybe can speak to this, but typically in water utilities that I've been involved in, I think the law is such that you can go back 3 years. You don't have to go back beyond that.
Or
Huh?
I think 4 years.
Yeah. So,
well,
and they didn't have any charges that were out of sync prior. It was just this period here that's in front of you today.
Is there any liquidity issue?
No.
Okay.
Good question.
So the agency has the liquidity for the refund. Okay.
We have about, well, as of the financial report at the beginning of the meeting, we have about $175,000. So
something doesn't seem quite right. I mean, for them to be, in that they were only in the 1s and 2s, and then they went to the 6,000.
Right.
And I know you looked at,
And Roberta went back and looked at the filings by the ranch.
Right.
And then,
right?
and then looked at what they paid and then recalculated to determine what should they have paid based upon the meter multiplier.
Uh-huh.
And so that's what's in front of you.
So did somebody misread the meter?
No,
they-
it's the multiplier. They didn't misread it. They just multiplied it.
They just did the improper calculation.
Correct.
So the fourth quarter of last year is when they said, whoa, there's got to be something wrong. I take it.
Yes.
Okay.
That's exactly what happened. She went and asked her father why it was so high. They were pumping so much. It didn't seem right. And he realized right away she was using the wrong multiplier. She was multiplying 10 times the amount that they actually were pumping.
Could we table this for a month, and could you put out the raw data, Roberta, to the board members, the meter readers? Just I'd like to just play with it for.
Okay. Yeah, we can do that. Not a problem.
What seems to be the issue, Jim? I'm curious.
I don't get why it's 3x suddenly in fourth quarter 20. If you were consistently doing it by 10, it was all hovering 1,500, 1,700, 1,600, in lows in sometimes, and then a 3x. Something just doesn't quite seem.
Well, they put in a new crop. So I think
No, I know Santa. I know this ranch.
okay.
Okay. Well, we can bring it back next month and I'll work with Roberta to get the raw data to you.
Thank you.
Okay. We have all the 700 forms that you all need to turn in if you haven't. You could get that to Roberta as soon as possible. And other than that, unless anyone has anything else, we will be adjourned. All right, thank you, everyone.
Okay, thank
Thank
you.
you.
At 4:51.